Today on Basic Bytes, I will be showing you how simple it is to dump a Commodore 128 cartridge ROM into a binary file which you can then use to emulate said cartridge in Vice, for example. As an added bonus, this Mach 128 cartridge contains a specific ROM revision that does not seem to presently exist in the ReplayResources archives. Therefore, I will also be uploading today's ROM dump to the internet for historical preservation. Greetings, it's JC at Basic Bytes, live capturing from an actual Commodore 128 for the first time, so check off another box for the channel. Today's topic is how to dump a Commodore 128 cartridge ROM using no special equipment really other than the computer itself. This is intended to be a generic tutorial which should work with a wide variety of Commodore 128 cartridges. What prompted me to do it at this juncture is, as you see on your screen, I happen to have an older revision of the Mach 128 speeder cartridge with ROM version 1B. This ROM revision does not presently exist in the ReplayResources archives at PokeFinder, and indeed it's possible that nobody has previously dumped or uploaded it anywhere. Thus, today's video also has a bonus element of historical preservation. As mentioned, I will be uploading this ROM to the internet for purposes of educational study, as well as archival of this code which is now considered abandonware and shouldn't be lost to history. I am not going to dig into the features of the Mach 128 cartridge today, since the cartridge is incidental and that's not the point of this tutorial. However, as a brief history for those of you that have never even heard of it, the Mach 128 cartridge is the successor to a Commodore 64 speeder cartridge called the Mach 5, which was released in the earlier part of the 1980s. The Mach 128 is an excellent and highly useful offering for Commodore 128 users, being one of the few speeder cartridges ever released that works with the Commodore 128 in both Commodore 128 and Commodore 64 mode. Going back to 1985, the new 1571 disk drive offered by Commodore, which I have previously opened and rebuilt in a video on this channel, offered an entire host of new features. At the same time, the only one of those new features that was really compelling for the average user was the fact that it operated finally at a respectable speed. Thus, for the typical home user, having a speeder cartridge that would speed up your 1541 disk drive to near 1571 speeds on your Commodore 128 in Commodore 128 mode could very well negate any need to purchase the new disk drive. More to the point of what we're doing today, it is useful to know that these particular cartridges contain a 16 kilobyte ROM chip. However, it is divided down the middle and holds two completely separate 8 kilobyte ROM images, one for the Commodore 128 and the other for the Commodore 64. If I flip the switch on the cartridge over to C64 and hit reset, it now presents itself as a Mach 5, having loaded the other 8 kilobytes of ROM. In either case, and in either mode, we have the full capabilities of a 1541 speeder cartridge available to us. I think that's quite enough about the cartridge though, so let's get to dumping the ROM. The first step of dumping ROM images may seem obvious, but it's figuring out exactly where and how you're going to save the files. In this case, I've created an empty D64 disk image called Mach 128 ROMs on my Pi 1541. You essentially have a few options here, and keeping in mind that you're going to need to get these files onto your PC, saving them to a physical diskette, such as in a 1541 disk drive, is probably the worst option unless you have something like a Zoom floppy, which then lets you hook up that disk drive to your PC in order to get the files off the disk. Although if you do have a Zoom floppy and need some assistance in setting it up, please see my recent video on that subject. A much better option, however, is to save the files into a disk image, such as a D64 on a Pi 1541. That said, your best option is if you have a mass storage device such as an SD2IEC, which lets you save program files directly to the file system of the SD card. That way, you won't need to extract them out of the disk image once you copy them over to your PC. The reason why I'm using a D64 disk image rather than mass storage is simply so that I can demonstrate how to get the files out of your disk image in the event that you need to do that. We are going to use the machine language monitor to examine memory and ultimately dump our ROM files, shortcut key F8. The first thing we want to verify is that our ROM code is actually visible in memory where we expect it to be. On the Commodore 128, cartridges bank in at memory location hex 8000. So, if we look at memory at 8000, oh, well that's not ROM code at all, that's just a bunch of uninitialized RAM. In addition, there's something else fishy going on here, because you'll notice it's a 4-digit address space, but it's actually giving us 5-digit memory locations, with every memory address being prefixed by a 0. Page 372 of our Commodore 128 System Guide has the following helpful note on 5-digit addresses. The Commodore 128 displays 5-digit hexadecimal addresses within the machine language monitor. Normally, a hexadecimal number is only 4 digits, representing the allowable address range. The extra leftmost high-order digit specifies the bank configuration at the time that the command is executed. A chart of bank configurations is included, and if you've ever used the bank command in the Commodore 128's basic version 7, these are the exact same thing. The only difference is that instead of specifying a decimal number from 0 to 15, we are specifying a hex digit from 0 through F. The bank that we want to be looking in is bank number 8, which exposes the external ROM. We could also use banks 9, A, or B. With this new information in mind, let's look at memory in bank 8 at 8000. And so that we don't get a ton of information on screen, let's go to address 8010. And immediately we are seeing code, and the CBM within this code gives away that we are in fact looking at cartridge code. Every Commodore 128 cartridge begins with a 3-byte cold start vector jump, followed by a 3-byte warm start vector jump, followed by 1 byte, which is typically FF. This is an auto start byte. It can be set to other values if, for example, you don't want the cartridge to auto start itself and you want to have to invoke a syscall in order to start the cartridge, but typically you will see FF here, followed by the 3 letters CBM. So, we have absolutely revealed that there is a cartridge ROM in bank 8 at hex 8000. The next question to deal with is, how big is this ROM file that we're dumping? Of course, in this case, we already know it's 8 kilobytes because, well, we already looked it up on the internet, but in the event that we didn't know what sort of an animal we were dealing with, we would have to determine that. Looking at this little chart, an 8 kilobyte ROM will bank in from hex 8000 through 9FFF, but a 16 kilobyte ROM will go all the way to BFFF. Therefore, if a 16 kilobyte ROM continues past 9FFF, one way of determining this is to look at A1000 and see if there's a continuation of the cartridge code there. So looking at memory in bank 8 from A1000 to A010, we do see code, but note that it is exactly the same as the code at 8000. This is a dead giveaway that we are dealing with an 8 kilobyte ROM because it hits the end of the ROM file and then simply loops all the way back around to the beginning. If we want to do the paranoid check, we can compare memory in bank 8 from 8000 to bank 8 at 9FFF to the code that exists in bank 8 starting at A000. You'll notice that command returned nothing. If any address in those two 8 kilobyte blocks did not exactly match, it would be displayed on screen right now. Therefore, we know that the code at 8000 is mirrored at A1000, and we are simply dumping an 8 kilobyte ROM. One warning that I will add before we move on is that although the Commodore 128 also supports 32 kilobyte ROM files, I don't believe that you'll be able to successfully dump one using the method that I am showing, and that it will in fact lead to a corrupt ROM dump. The reason goes back to the chart of bank configurations that we were looking at, noting that all of the bank configurations that bank in external ROM also bank in I/O. The Commodore 128's I/O space lives in the D1000 block, whereas a 32 kilobyte ROM file goes all the way from 8000 to FFFF, and thus intersects the I/O space. That said, I myself am still very much learning about the Commodore 128, and I have had no occasion so far to actually try to dump a 32 kilobyte ROM file. If anyone out there does have experience with this, does happen to know if the D1000 corruption occurs, or if there's a workaround, and if it's an easy workaround, I would appreciate your insight in the comments below. To save our ROM file to disk, we're going to be using the save command, which is the machine language monitor's equivalent of the bsave, aka binary save command that exists in the Commodore 128's basic version 7. The syntax of the command that I've typed here on screen is 100% correct and should work fine, but most of the time it doesn't, so let me step you through it. To save from memory, we're going to save our desired file name to device 8 from bank 8 at hex 8000 to bank 8 at hex A1000. This is one of the gotchas of this command in that the ending address needs to be 1 byte beyond the address that you wish to save. This will actually save from 8000 to 9FFF. If I put an ending address of 9FFF, then that final byte would in fact not be saved. That particular gotcha is well documented in the manual. What isn't documented is that trying to save out of bank 8, in other words, trying to save a cartridge ROM directly to disk, almost never works. In fact, most of the time, the 1541 just keeps spinning endlessly. To be clear, I have tested this on Pi 1541, Vice Emulator, and an actual 1541, and the same behavior occurs on all three. So it isn't a firmware or emulation problem. There is some actual problem trying to dump a cartridge ROM to a 1541 disk that makes it fail and go into an endless loop most of the time. To solve this problem, we just need one extra step. We're going to copy the contents of the ROM into the Commodore 128's RAM, then we're going to dump the RAM to disk. Thus far, at least for me, dumping from RAM to disk has worked flawlessly. To copy the 8 kilobyte cartridge ROM into RAM, we're going to transfer from bank 8 at address 8000 through bank 8 address 9FFF into bank 0, which is 100% RAM at address 8000. We should now have an identical copy of the ROM in RAM. Let's check that. Looking at memory in bank 8 from 8000 to bank 8 at 8010, we once again see the starting bytes of our ROM. Now, if we look at memory from 8000 to 8010, noting that the leading 0 is not required if you're looking at bank 0, we now see a copy of the exact same code in RAM. And once again, to do the paranoid check, we're going to compare memory from address 8000 to 9FFF to the contents of bank 8 at 8000. And here we see that no different bytes were flagged, meaning that we have verified an exact copy of our ROM into RAM at location 8000. At this point, we can finally and confidently proceed to save our Mach 128 1B to device number 8, and we are saving memory location 8000 through 9FFF plus 1, which is 8000. I cut out a few seconds of save time, but just like that, our ROM file is now dumped to the disk. While I'm here, I'm going to do one additional thing that I found this particular cartridge enables. It turns out that if I flip the switch on the cartridge over to Commodore 64, but do not reset the computer into Commodore 64 mode, now if I look at the memory in bank 8, we actually see the Commodore 64 ROM exposed. If I switch the screen into lowercase, notice you now see CBM80 Mach 5. The CBM80 is the flag for a Commodore 64 ROM and tells us that that is now what we're looking at. While I'm here, I'm going to take the opportunity to dump my Mach 5 1B ROM as well, just in case it happens not to be the same as the Mach 5 1B ROM that already exists in the ReplayResources archive. To do this, I simply need to rerun the transfer, re-verify that RAM now has a copy of the other ROM, re-verify that the entire 8 kilobyte block is identical, and save this new file as Mach 5 1B. I've once again cut out some of the saving time, but that should be our second ROM dump complete. Having reset the Commodore 128, let's take a look at the contents of our disk. And there we have it. 2 files of exactly the size we expect them to be saved to our disk image. It's now time to turn off the Commodore 128, take out the SD card, and go to the PC. Switching over to a command prompt on my PC, I have copied the Mach 128 ROM's D64 file into the bin subfolder of my installation of Vice. There are other programs for Windows that can extract the contents of a D64 disk image, but I assume that the average viewer of a video such as this one is already going to have the versatile Commodore emulator. If you don't, I would highly recommend getting a copy. There is no installer, just download it and extract it to a folder of your choice. The bin subfolder contains many things, including the programs and utilities that are a part of Vice. One of these utilities is a command line emulator of the Commodore 1541 disk drive called C1541. All we need to do is point it at our Mach 128 ROM's D64 file with the extract switch. And we didn't get any error messages, and no news is good news. If we take a look at what we got, we now have both of our Commodore 128 memory dumps extracted from the D64. As previously mentioned, if you were using a mass storage device that allows you to save program files directly to the file system of an SD card, then you simply copied these two files onto your computer and did not need to do the D64 extraction. Either way, old-school programmers who know their factors of 2 better than they know their own phone numbers will have already spotted the next problem. An 8 kilobyte ROM file needs to be exactly 8 kilobytes, which is 8,192 bytes. Notice that the files we just extracted are 8,194 bytes. To realize from whence the extra 2 bytes came, we must remember that we saved these to disk as program files, which means that the Commodore added a 2-byte header to each file, specifying its memory load address. In order to get working ROM files, we need to get rid of those 2 extra bytes. Open the file that you saved on your Commodore 128 in any hex editor of your choice, and you will immediately see a bunch of familiar bytes at the start of the file, including the telltale CBM. However, you will also see 2 additional unfamiliar bytes at the very start of the file, which we did not see in RAM in the Commodore 128. These 2 bytes represent the sort of header that is added to every Commodore program file, and this represents a load address of 8,000 hex in low byte, high byte format. In order to get a working ROM, we need to delete these 2 bytes and then save the modified file with a .bin extension, which is the standard extension for this type of file. Once again at the command prompt, you can see here that we have saved our 2 modified files without the 2-byte header with a .bin extension, and they are now both the correct size of 8,192 bytes, which is 8 kilobytes exactly. Whether or not you are completely done at this point depends on what kind of a ROM you dumped and what your intended usage of it is. A Commodore 128 binary ROM file works just as well for EEPROM programming as it does for use in an emulator such as Vice, the latter of which I will demonstrate in a moment. The reason for this is that the Commodore 128 cartridge ROMs, or external ROMs as they're officially called, are completely software detected, which means that the Commodore 128 doesn't require anything other than the software code within the ROM file in order to configure that cartridge. Commodore 64 ROMs, on the other hand, are a different animal. A binary Commodore 64 ROM file is what you want for programming an EEPROM, but it is not in a state where it can directly function with an emulator such as VICE. Commodore 64 cartridges announce themselves to the system via their hardware configuration, and thus in order to get a Commodore 64 ROM file working in an emulator, it needs to be converted to a cartridge file with the extension .crt containing an extra header which tells the emulator exactly how the hardware of that cartridge is configured. The utility to convert a ROM file to a cartridge file is also included with VICE, and it is called cartconf. I am not going to get into the weeds of cartconf here, firstly because this video is mainly about dumping Commodore 128 ROMs, and secondly because this utility is so well documented in the VICE manual that you can really just read the documentation for yourself. I will, however, run this one example for you as a demonstration. To convert a binary to a cartridge, you need to determine the correct cartridge type from a list of provided types, which in this case happens to be Mach5. Specify an input file name, specify an output file name, and optionally specify a name, which is a text string that will be embedded into the cartridge file header, and run this command. And the conversion was successful, noting that the load file size of 2000 is in hex, not in decimal. If we take a look at what we have now, there we have our Mach5 1B cartridge file, 8,272 bytes including the header, and that should now work with VICE emulator for the Commodore 64. And finally, the way that you get a Commodore 128 ROM file working in VICE is you go into your Settings, Machine, Function ROM, set your external function ROM type to ROM, and then point it at your ROM file. And then reset the emulator. And there it is, a Mach 128 version 1B ROM successfully working in VICE Commodore 128 emulator. But wait, there's more. If you're interested in the ROM files that I created during this video, head on over to files.basicbytes.ca and take a look inside the C128 folder. Oh, and by the way, the Mach5 version 1B ROM that I just saved does not match the code contained within the Mach5 version 1B ROM over at ReplayResources. It is, in fact, a different revision, even though it shares the same version number. Within the archive, I have included a README file containing the information that I know, and you can go and check that out. But in the meantime, if you found this interesting or entertaining, please like and subscribe to Basic Bytes for more. Also, if you have anything further regarding the dumping of ROMs or the Mach 128 cartridge that you would like to add to the conversation, please feel free to leave a comment. Thank you for watching.